Well, good morning, Year 11. Welcome to Monday morning classes. And today we're going to look at transformations, function transformations. This is our last little section, really, for this unit on functions. It's been quite a heavy unit. We've covered quite a bit of stuff. Wednesday, I want to give you a term test, and I'll explain how that'll work later. But let's get into transformations. Transformations essentially are changes to graphs as functions are tweaked. Now this word tweaked, as they're adjusted, as they're manipulated and messed around with. So we're going to look at functions and look at 4 basic adjustments. Now, if you have a look at my little function machine down here in blue, we've got our inputs and outputs. Obviously, X representing our set of inputs being our domain, Y our set of outputs being our range. Okay, and here's our function of X. This is where it's all going to happen in here. Now, what we're going to look at we're going to look at taking f of x, the function, any function, doesn't matter what it is. In a minute, I'm going to bring up Desmos and show you the graphical changes that result from changes in here. But it doesn't really matter what function we start with. I'm going to have a cubic on show. But whatever that function is, what happens when you go in and make changes in these places here? So either internally, I'll talk about these areas here being internal at the input level, or external in this spot here, in these spots here. So let me explain what I mean. So at the internal level, I say that these are changes happening within X, inside. So these are X level changes, and they affect the horizontal behavior of the function, the horizontal behavior. So we have shifts left and right. We have shifts horizontally, either translations or dilations. Okay, and the same idea for this level of adjustment. I say these are at the Y level. These are kind of external, and they have a vertical effect on our function, on the graph of our function. So let me show you what I mean. Okay, so I'll drag down. These are the notes I'd like you to, I guess, take away from this. Take away from this screencast. And there are three transformations we're going to look at. We're going to look at translations. You should be familiar with translations. They're just the shifts, up, down, left, right. Reflections, again, familiarity with that, I think. Reflections, symmetrical reflections. We looked at this, didn't we, when we were talking about odd and even functions having that reflection across the y-axis. So reflections are a transformation that we can look at, and dilations, finally, where dilations are stretches or compressors. And so depending on what the value of the multiple is that we throw in there, that'll change the dilation to a stretch or a compress. And again, if it happens internally, it's going to be a horizontal. If it happens externally, it's going to happen vertically. So at the X level, I'm talking about it being internal. So let's have a look firstly at that. And in green here, I've just made that little note of input equals external, horizontal, output level equals vertical. So that's the first thing I want you to look at, really, when you're having a look at a transformation. I want you to size up, decide whether it's an internal or an external adjustment or tweak that is taking place. So let's firstly have a look inside here. So I'm looking with reference to this function here. Have a look at the setup. It's a cubic, and you can see right at the top there how f of x is defined. And then underneath you can see here are my 4 areas of adjustment. I've got adjustment in at A, at B, at C, and at D in those positions. So let's firstly have a look at just changing this value of C in here. So it's internal, it's at the X level. So what I mean by that is when I go in here, and I might put a little, I don't know, might put a little +2 in here. So everything else stays the same. This is 1, right? No change to that. This is 1, so no difference to that. And I'm just going to make that 0. So I'm just looking firstly at what happens when I put a little +2 or +3 or a -5 in there, what is the effect? Now let's have a little think about it before we go and check it out graphically. What that means is, all right, so what I'm asking for the same output, now my input for x has to be reduced by 2. So so what was there originally, I now have to have 2 less for x to get the same output for y, if you get what I mean. Because if I put in 2 less, that'll balance this +2 out. So that's why we see the effect we're about to see when we add 2. So I'm going to change this value of c now, and I'm going to drag this button across to +2, and you can see as I go across, there we are, the blue curve has moved 2 to the left. That's x being reduced by 2 to counter the +2 that I've just put inside the bracket. Now if we go the other way, then clearly what I'm going to get is, if I go to -2 for instance, then what's happening there is everything moves right, because what's happened is, if I'm going to +2 here, so if I'm going to -2 here, then I need to add 2 to all my x coordinates to get the same y coordinate. So whatever was happening over here for, let's pick out a value on the original curve. So where, say, x was equal to, well, I don't know, where x was equal to 2, I got, looks like -1 or thereabouts. Now to get that same y value, I have to go over to 4 to get that value of -1. So I've shifted, everything's moved across 2. Okay, so that's the effect, that's the internal effect of the inside the bracket. When we do something like taking f of x +3, that's internal. Okay, so that has a shift left, and I've made that point here in a translation. When we go right and left in green, we've got the horizontal movements in each of my 3 transformations, and in blue we've got the vertical. So I've just covered these first 2 here, where we're moving horizontally when we just adjust this value in here, just inside. Now the other adjustment inside is this one right here. So I'll just get rid of those markings. Okay, so what we're looking at now is taking a value of, I don't know, say 2x here. What happens when we do that? Now the adjustment again is at the internal level, because to counter that, I'm now going to have to take all my x coordinates and I'm going to have to halve them in order to get the same output. So I take whatever went in for x before, maybe it was 4, I got my output. Now I'm going to have to halve the 4 to get 2 to get the same output. So what the effect of that is, if you can think about halving your x, every value of x, then that's going to have a compression effect on my curve. Right, let's have a look at that compression effect. So I'm going to go back to c being just 0, and now I'm going to go to b. Have a look what happens to b. Have a look what happens to this curve as b increases. So I'll push it out to 2, and there it is. Look at that. Look at that compression effect squeezing into the y-axis. Okay, and the further I go, the tighter it comes into the y-axis. Okay, so that's when I go larger than 1. Okay, and I'll show you where that's reflected in my notes. So that is, we're looking at the input. We're skipping reflections for a sec, going down to dilations. So when b got greater than 1, that was what we just looked at, this point here. When it compresses horizontally towards the y-axis, squeezes in towards the y-axis by scale factor 1 over b. Okay, so as b increases, I looked at 2, so it was a half, scale factor a half. When b was 3, it was scale factor 1/3. But importantly, it's a compression. Let's have a look at now what happens when b is between 0 and 1. So let's have a look in here, b between 0 and 1. So let's squeeze b in tighter and look what happens. So should have done a little prediction there. So go back to my notes. So now what I'm doing here is I'm changing this value here to one that's between 0 and 1. So let's say it's 0.5 or a half x in here. What happens to my x now is I need to double my x in order to get the same output. So whatever x I had in there before, again, maybe I had 4, it now needs to be 2 because, sorry, it needs to be 8 because I'm going to halve it before I apply the function. So to get the same output, I'm going to have to double all my input to get the same result. So that's the effect of having a number in here between 0 and 1. Let's have a look at Desmos. So as B hovers between 0 and 1, have a look at this. We should take it down towards a half. What's happening is that all my x's are doubling. So that is a stretch. That's a horizontal stretch. Remember, it's all horizontal at this level, at the input level. So that affects a stretch. A number in here between 0 and 1 affects a horizontal stretch where that curve is being pulled away from the y-axis. See how it's being pulled away from the y-axis? Okay, so take it back to 1 and check our notes. Back to 1, check our notes, and here it is in here in green. So I'm stretching horizontally away from the y-axis by scale factor 1 over b. So at a half, at that example of f of a half x, then that scale factor 1 over b, 1 over a half, which is equal to 2. So my scale factor would have been 2. And it's pulling away and it's a stretch. Okay, so I've covered the green spots. Now, in a way that's more intuitive, the y level, the vertical responses are more intuitive. So let's have a look at, firstly, perhaps this number on the end here. So I'm going to remove this. They're all now going to go back to 1. That's staying as 1. This is staying at 0. And now I'm going to change this value here to say 2. So this is now at the output level. And you can see what's going to happen for the same x. What's going to happen is that y is going to go up 2 here. If I put -2, y is going to go down -2. So by the y level, external level, I'm saying that the function level's been the function's been calculated. I'm just putting a +2 on the end here. So what happens there is at the output level, I get 2 more for the same value of x. For my same input, I get 2 more if I put a +2 in there. Now, there won't be any surprises here as I just move my value of d and my function just goes up 2. Everything shifts up 2 or down 2. But again, importantly, it's a horizontal effect. Sorry, a vertical effect, because now I'm dealing at the external y level. So that will have the effect, and let's go down. This is my translation vertically, up by k units for +d, where d is greater than 0, and -d vertically down by 2 units, by d units. Let's have a look at how the dilations work. So reset that to 0, and what happens now when I change this number out the front to something other than 1? So now my whole function is multiplied by 2. Well, what happens is all my y values just double. So for the same x value, my y values double. So that has a vertical stretch. For 2 has a vertical stretch. Now I'm playing with the values of a. Look at what happens and see that being pulled away. So that what we say there is that is a stretch, a vertical stretch, as the function is being pulled away from the x-axis. See how it's being pulled away further and further as a gets larger, and the scale factor is a. Okay, so back to 1. What happens when a is between 0 and 1? Well, you'll see here a compression. So the function is compressing in towards the x-axis, and the scale factor in this case is 0.6 at the moment. So let's go back and see how that looks in our notes. So that was a dilation, and there we are there. So when a is greater than 1, it's a stretch vertically away from the x-axis, and when a is between 0 and 1, it's a compression vertically towards the x-axis. Okay, fair bit of stuff here, isn't there? But hopefully it's coming together for you. Now, the only other thing to look at is what happens when we have a when we just change the sign in here. So if we just put a little, what happened to my x? When we just put a little, say, a negative in there, or a negative out the front again. So let's have a look internally. If it goes in there, it's an internal, oh, my bracket's gone as well. It's an internal adjustment. So what do we expect? We expect a horizontal reaction. And that horizontal reaction is a reflection. So let's have a look at how that works. So I'm just going to change this value in here of b, and let's just flip that around to -1 and watch what happens. I'm expecting a horizontal reaction, and that is a reflection in the x-axis. Have a look and go to -1,